Bill, you're my tester. Can you hear me?
Yes, I can hear you, Jess.
Perfect, thank you. Because I'm doing the group on mine. I was like, fudge, I need to be make sure that my mic works.
Okay, your mic is working perfectly.
Thank you.
I just be in here just in case. I don't know. I'm not at school right now. That's why.
Oh, see, we're all grouped together right now, so we're all trying to go over it.
Yeah.
Yeah.
Good afternoon, Dr. Tran.
Hey Bill, how's it going?
Pretty good, pretty good. So we not in lecture, yeah, okay. I
Oh,
just curious.
oh yeah, yeah.
Yeah,
We're good. We're gonna do all the presentations virtually.
all right, for
Yeah,
sure.
just because it's a little bit easier a little bit easier for me to kind of see what's going on too.
All right, for sure, for
Yeah.
sure.
Professor, can you hear me?
Yeah, I can hear you.
So we have our group just on my Zoom. I wasn't sure if that was okay.
Yeah, that's perfectly fine.
Okay, cool.
Hmm? All right, first group. So we have BP oil spill first. So James, Danny, Brighton, Luke, Saka, you guys all here?
Yeah, I'm here. James is here.
Okay, which one of you guys has the slides? I need to give you guys a hosting privileges.
I think we're deciding that right now. I
Okay.
don't know. I think, let me see. Uh, is Brian here? Brian, did you wanna
I'm here.
screen share it?
Yeah, I can share it.
Okay. Let me make you co-host so you can do that.
Sounds good. Give me one moment to get that started.
Nice.
Okay, is that showing up for everybody?
Yep, I can see it.
Oops.
All right, it's 1 o'clock. Let's go and get started. All right, good afternoon, everyone. Welcome to the final week of the semester. So as you guys know, this week we just have final presentations. So I won't say too much. We'll just kind of jump right into it. So the first group that we have today is looking at Deepwater Horizon. So this is the BP oil spill. So is everyone, Brighton, James, everyone in your group here? I think I saw Danny, but Luke, I think I saw him too.
Yeah.
Okay. Where is Zaka here?
Saka, are you here?
I think he's just connecting.
Okay. All right. We'll wait a couple minutes, but so let me just go over the logistics a little bit. So since we only have 4 groups presenting each day, you guys have a little bit more time. So I'll set a timer for 18 minutes. I'll give you guys some cues in the chat. Basically, when you're running out of time, I'll give you a cue at 10 minutes, 5 minutes, 2 minutes, and 1 minute. And then after that 1 minute's up, then I do have to cut you off just to make sure that we have time for everyone else. So for 18 minutes per presentation, and then maybe like a minute changing between each one, I think we should be good to go. All right. So first group. So as soon as Zaka gets here, you guys can start.
I think he's later in the presentation too, so if he doesn't show up here in the next couple minutes, we can just start.
Okay. No, I think he's here.
Okay.
Okay. Go ahead and start. I'll start the timer when you guys flip the first slide.
All right, so we're going to be starting here with the Deepwater Horizon disaster. This was the oil spill that occurred back in 2010 on April 20th. So we're going to be looking into the whole case. The first slide here is just showing the aftermath after it actually exploded. So after the kick happened, which is where when you're drilling down underneath, there's a kick that can occur where the the pressure of the oil is so high that it actually comes up extremely fast. And there are preventative measures to prevent this, which we'll get into. But after it kicks and comes back up to the platform, then it's able to be ignited. And that's what you're seeing here, is that after it got ignited, then the whole platform had gone up in flames. And this is it getting watered down. So just to go over a quick timeline, we do have April 20th as the initial explosion, and that's when the spill began from underneath. On May 6th, 3 containment domes arrived on the scene, which was actually a fail. So they were getting oil under a large metal container that would trap it and pump it to the surface, but this unfortunately did not work. On May 9th, there was a proposal of a junk shot, which was literally to blast junk pieces of rubber and other rubbish onto the pipe to hopefully stop the spill, but no surprise there, that failed as well. On May 13th, Steve Worley, who was a researcher, he came out and said that there was an estimate of 1,000 to 5,000 barrels per day that was escaping into the ocean. But turns out this statistic was very off, and it was actually closer to 70,000. And not only that, but a week later, on May 20th, was showing even a larger range of that, from about 20 to 100,000. But just to back up a little bit, on May 14th through the 16th, a tube is inserted, and it is able to draw 5,000 barrels per day up to the surface, which is doing some prevention, but still, given that that estimate on May 20th is very, very high. On May 26th, BP starts pumping mud into the well known as Top Kill, which continued to fail. And on the 4th through 6th of June, they placed a cap over the valves, which was somewhat successful and captured 10,000 barrels per day of oil. And then as time went on, there was a lot of political folly for the next 2 months, and with no significant advancement in plugging the well, until we did have an official static kill, which was successfully plugging the oil well as they pour cement to permanently seal where it was escaping from. So just to introduce this a little bit, the image you're seeing on the right is down at the base where the oil was escaping from. And this was due to just the whole spill in general was due to a lack of precautions and regulation for fail-safe measures with profits in mind. So with oil being such a high demand at the time, there were a lot of cut corners. And there were a total of 11 lives lost, which were initially that they were not found. They were missing for a while until they were confirmed dead. And man-made environmental disaster at this scale hadn't really been seen. And there was clearly a huge priority for quantity over quality when it came to this mill. So this resulted in billions of fines, which was way more than the profits that would have been if it had lost, if proper risk management was implemented within the structure of the company. So just to give a little bit of historical context of the whole operation, and just to oil rigging in general. So they were actually onshore until around the end of the 19th century. Oil rigs had only gone up to the shoreline up until that time. And it was only after this point that piers began being built out into the water to extend our ability to drill oil. Off the shores of California, Summerland oil field, which was led by Henry L. Williams and his associates. They built a pier that was about 300 feet out into the water and had a mounted standard cable tool rig on it. Other companies followed, and for the next 25 years, Summerland was showing drastic growth in California's economy. But the first freestanding oil rig was in the Gulf of Mexico, which began drilling in September of 1947. And that was producing about 40 barrels of oil per hour, which sounds pretty high, but compared to what Deepwater Horizon was producing of around 53,000 barrels per day, that does seem like they didn't improve their technological advances over that time. In the bottom right, you can see the total oil platforms in the Gulf of Mexico in 1990. The shallow water are all the red dots, and the deep water drilling points are all the yellow dots. So after Deepwater Horizon, there were many court hearings that preceded the explosion, which brought to light many of the ongoing issues at the time. So there were some claims made by Jared Jennings. He was a caseworker at the time. He worked for the multi-district litigation, the MDL, out of Louisiana. And he worked on document reviews, deposition preparation, reviews and summaries of depositions. And he also represented clients from Texas to Florida whose businesses were impacted by the contamination of the water. And some of the things that he was able to bring to light was that Cameron Engineering, there were some of the engineers that were working on the BOP, which is part of this preventative system down at the base of the water. They had modified it. Transocean, which is one of the companies running the rig, was cutting maintenance at the time. And BP had also asked Halliburton for a cheaper slurry, which is also called drilling mud. And that's it creates a barrier between the undersea oil and the gas and the piping that leads to the rig. If this fails, the blowout preventer at the seafloor is the last-ditch effort to prevent catastrophic failure. James is going to have an image of all these mechanisms I just described in a couple slides. And then last thing I'll state is that Mike Williams, who's the chief engineer for Transocean, he stated that the alarms were inhibited. And what this means is that the sensors went off because there's several alarms that are supposed to go off in case of this accident. And the crew had seen these indicators, but didn't sound the alarm because they were told they didn't want to wake people up at 3 a.m. by false alarms. So this was clearly a lot that was led into the issue where it was not a series of unpredictable, unfortunate events. This was fully preventable.
Okay, moving on to the technical context. I'm James, and I'm going to go over the technical and economic context in regards to the BP oil spill. There are loads of different types of engineers involved in oil rigs, but it mainly consists of civil and mechanical for the structural, drilling, and maintenance aspects of the rig, as well as petroleum or chemical, since it deals directly with oil and hydrocarbons. Chemical engineers also would be responsible for making sure the densities of the concrete were appropriate in regards to the pressure of the well when laying the foundation at the seafloor. Some other fields of engineering are electrical and computer for monitoring the systems found on board, as well as environmental, which would help determine what to do with the waste. BP was a little different than other drilling companies because they were so large, as they were one of the earliest to get into drilling for oil in mass quantities, but they also neglected risk management and made an effort to make deadlines and limit the amount of delays that occurred. It could somewhat be seen as a reflection of their stock price as it was continually climbing in correlation with the world's demand for oil. Some specific technical details regarding the rig were that its official name was the Deepwater Horizon and was owned by Transocean and being leased to BP. It was located in 5,000 foot deep water, and the drilling of the well was at a distance of 18,300 feet in the Macondo prospect in the Gulf of Mexico. I'm going to skip over this next little part. Can you go to the next slide? So that was the final solution. Go ahead and go to the next slide. We're kind of strapped on time. The economic context. So moving on to the economic context, Hyundai Heavy Industries started construction of the Deepwater Horizon in 1998 and finished and sold the rig to the Transocean in 2001 for approximately $350 million. The rig was then leased to BP in 2001, and the lease was renewed or extended all the way through 2013. Leasing the rig had a cost of around $500,000 a day, based off of the last 3-year lease being $544 million, and dividing that over 3 years. Additional operating costs like crew and other supplies cost about another $500,000, so the total operating cost per day was like $1 million a day. Deepwater Horizon was one of the top end rigs of the time, and estimates were that it would have been able to bring in around 53,000 barrels of oil each day. As seen on the chart, oil in 2009 through 2013 was within the range of $70 to $110, so the calculations would show 3.7 to 5.8 million in revenue per day, and subtracting off the 1 million operating costs, it would have been bringing in 2.7 to 4.8 million profit each day, depending on the price of oil. Now, on to the last slide. I'll briefly go over the main fines that BP had to deal with over the years. There were penalties and fines of 4.5 billion in 2013 after BP pled guilty to felony manslaughter and lying to Congress. There were natural resource damage claims under the Oil Pollution Act and to the sum of 8.8 million for the millions of gallons of oil spilled into the Gulf. Another 7.8 billion in 2012 that was awarded to go to the individuals and businesses directly affected by this bill. And the biggest and main settlement with the United States government and the 5 Gulf Coast states that totaled 20.8 billion in 2015, which was the largest settlement with a single entity in the history of the United States Department of Justice. I'm going to skip over this next part to pass it on to the next person.
All right, for the personnel context, their jobs were to make sure everything was going smoothly and that there were no problems surfacing that could lead to possible dangers. The Halliburton, which was the contracting company, created the concrete core that got blasted and allowed for natural gases to travel up the pipe system. And according to investigations and trials, BP was found 67% liable. Transocean was 30% liable, and Halliburton was 3% liable for the cause of the oil spill. And then moving on to the personnel themselves, we have Kurt Mix, who was a former senior drilling engineer and was charged with obstructing justice. He is the person with the hard hat on, and he was found deleting text messages on the oil flow rates when he had received prior legal notification regarding the oil spill. Robert Kaluza, which is the person on the bottom left, and Donald Vidrin, the person on the right, were both former senior drill engineers, and they were both charged with involuntary manslaughter and gross negligence. And then for the main cause of the ethical dilemma, there was negligence in the maintenance, safety, regulation, and inspection of the oil rig by the supervisors and higher ups. There was also the idea of profit maximization, where BP and Transocean wanted to make a higher profit, which caused them to ignore the more valuable and necessary safety measures. The effects of their ignorance and negligence led to the oil spill, which exceeded all of their safety precautions. And as a result, it led to a loss of billions of dollars as well as the lives of wildlife. And it was deemed one of the greatest national environmental disasters, which is still currently affecting the world today. For the ethical dilemma, it is shown that Transocean, BP, and Halliburton broke the ethical code of ethics. According to the IEEE code of ethics, it states that it is mandated to uphold highest standards of integrity, responsible behavior and ethical conduct in professional activities. What this is saying is that the companies to blame for the oil spill did not follow the codes of 1 and 5, where Code 1 talks about the safety and welfare of the public, as well as disclose the factors that endanger the public and the environment. Code 5 describes the honesty and correction of any errors that may cause problems for the company. And seen the safety welfare of the public was violated, and when the companies were put to blame for the act, some members decided to provide false information and delete crucial data. For the NSPE Code of Ethics, engineers are hold the safety, health, and welfare of the public. They're also to issue public statements with an objective and truthful manner. These codes were broken when their negligence towards
Hey,
the
sorry to
safety of
interrupt
the.
you. We need to move on to the next person. Just go to the next slide.
So the impact of the ethical issues, pictured above, you could see a pelican covered in oil. The effects of this caused ecosystem disruption as the food chain was disrupted. Fishes were dying and pelicans were getting covered in oil, causing the death and health issues, and end habitat degradation and long-term health declines. On the right, we have pictured above are tar balls and mud, oil, and tar, all tarnished natural sea and land life, had to be cleaned, and multiple barrels were being removed daily. Next slide. Right here, we have the impact of the ethical issues. Deep sea life effects, smothering of habitats, direct toxicity correlating to decline in population, resulting in food chain disruptions for both human and animals. Inland human life effects, exposure to oil causing health disruptions, cancer due to the oil, respiratory issues due to the fire that was caused, and then nausea, but not limited to headaches. Economical impact, multiple shareholders in the company were involved, but also some weren't. Individuals conducting business such as fishermen, tourism, but not limited to hotel owners, charter boat operations, and seafood operations. The entire chain of jobs was kind of disrupted due to the fire or the oil spill. The psychological impact, residents of nearby communities, people involved in causing the spill, members of community who lost their livelihoods. So all the job losses that occurred, the members of the community were left jobless due to this. Social disruptions, the social support system was just destroyed due to the backlash.
All right, you guys, you can finish this slide, but this is the last one. We got to move on.
Okay. So the what if or the ethical choices, first course of action would have been early disclosure and transparency. If the board of trustees, not limited to the engineers, had disclosed the full extent of the project and the risks that they're willing to take, or that the risk they take in engineering the parts, this wouldn't have happened. Stated in the IEE Code of Conducts, and then the NSPE Code of Ethics stated the engineer shall avoid deceptive acts. This would have aided in the public's trust with the company and their operation. The second possible course of action, the stakeholder engagement and participation. Could BP have engaged with their stakeholders, local communities, indigenous groups, environmental agencies and organizations, the scientific experts throughout the decision-making, the process? Sorry, I kind of blanked out. In the engineering world, light is shined on men and women who show interest in the benefit rather than.
That's it. We got to move on. Sorry, Zaka.
Sorry.
Yeah, really interesting, guys. Just yeah, but we just got to move on. So really quick, let's give these guys a hand. Okay, so next group that we have is Fukushima. So Andrew, Alexis, Christian, Andy, you guys all here?
Yep, I'm here.
Okay, who's sharing the screen?
I think the guys who are in class.
Who's Andy? Are you you guys have the slides?
Yes. Yeah, it's all of us.
Okay, I'll make you the co-host. Okay, you guys can share. You guys can start whenever you're ready.
Sure. Okay, so for a group project, we we did the Fukushima Daiichi nuclear power plant. So this power plant was critical for Japan's energy, and an incident occurred in March 2011 where the nuclear reactor experienced a meltdown. This,
Oh, 1 second, we're having technical difficulties. Can you go on your
sure.
Oh, we're gonna switch laptops real quick. Can you change the co-host to Alexis?
Hello? Hello?
Yep, I can hear you.
Okay. Okay, so for our group project, we did the Fukushima nuclear reactor. So the Fukushima Daiichi nuclear power plant was critical for Japan's energy. An incident occurred in March 2011 where the nuclear reactor experienced a meltdown. This incident was triggered by an earthquake and tsunami, leading to reactor failures, explosions, and radioactive leaks. And this resulted in massive evacuations, environmental damage, and profound socioeconomic impacts. So this incident raised ethical concerns about balancing energy needs with public safety, and it also sparked global debates on nuclear safety and engineering ethics. And then this is just an image of the results of the tsunami.
All right. I'm Andrew, and on March 11, 2011, Japan's largest earthquake hit with a magnitude of 9.0. And the first wave of the tsunami hit Fukushima Daiichi at 13 feet tall. And there was supposed to be a defense wall that could defend against 33 feet tall tsunamis. So it blocked the first wave. And then the second wave was at 50 feet tall, and this ended up flooding the nuclear power plants. The flooding caused power to shut off, and this resulted in the reactors to lose its cooling, and pressure then proceeded to build up inside the reactors. So TEPCO, the main company, decided to release some of the pressure, and this would result in radioactive material to be released as well. But not enough pressure was released at the time, and the reactors ended up blowing up as well. And this resulted in a 12.4-mile evacuation radius. And for technical context, nuclear power plants use nuclear fission. This is when a neutron passes through a nucleus, and the nucleus splits into two, and then two new neutrons are formed. This happens over and over again without any intention of stopping, and this process exerts energy as heat. And using nuclear fission, the heat exerted is transferred radioactive water to the safe water through heat exchangers. Using heat exchangers allows for radiation to stay isolated, and the safe heated water becomes steam and spins the steam-powered turbines, creating electricity. The steam-powered turbines are also used in fossil fuel plants, and besides the nuclear waste, nuclear fission is way cleaner. Over time, the material used in nuclear fission, which is uranium, becomes unusable and has to be trashed. But you can't just throw it away in a trash can. So options are to either dig deep underground or leave it inside deep pools inside the power plants.
It took 10 years and $2.2 billion to construct the 4 reactors damaged in the accident. In 2016, Japan's Ministry of Economy, Trade and Industry estimated the total cost of dealing with the accident to be a total of $187 billion. $69 billion were paid for compensation to people and businesses that evacuated due to the accident, $35 billion in decontamination costs of the Fukushima prefecture, 14 billion in cost for storage of radioactive materials, and 69 billion in cost of decommissioning the reactors. And this is just a table of all the costs so that you can visualize the amount for each one. Keep in mind the cost for building the reactors was just $2.2 billion. TEPCO was the main fault in the Fukushima disaster, specifically the top 3 executives of TEPCO at the time of the accident. Referring to the picture up top from left to right, we have Sunhisa Katsumata, Ichiro Takekuro, and Sakemuto. These were the main people who were responsible for the planning and construction of the nuclear site. They ignored improved tsunami safety measure plans in order to not delay operations of the nuclear plants. These safety measures would have prevented the accident from a tsunami like the one that hit on March 11th. However, the 3 executives were put on trial for criminal negligence, but were found not guilty as the court decided that the defendants could not have predicted the tsunami. Also, Masao Yoshida was the manager of the Fukushima nuclear power plant. He was a nuclear engineer. He stayed on site and he worked to vent the units and cool them down with seawater. Despite being ordered to stop pumping seawater into the units by a TEPCO manager, he continued to keep doing so, which averted a much bigger disaster. Yoshida had evacuated majority of the plant, leaving only him and a hand-picked group of colleagues that would stay and potentially die. These were also known as the Fukushima 50. Because of Yoshida's efforts to continuously cool the units and defying TEPCO's instructions, he was able to minimize the damages.
So the Tokyo Electric Power Company had a few ethical lapses. They chose to value the short-term profit and power production over the safety of the local residents. A quick example of this was, as stated before, they tried to prevent the employees from dumping seawater on the cores, as this would damage them and cause them to be needing to be replaced, but that was expensive and they didn't want to do that. So the main reason for the lapse was poor safety culture, regulatory failures, and failure on the individual and corporate level. From the corporate side, it was failure to respond quickly and report any and all information to the locals, which resulted in a really slow evacuation. The ethical issues that were presented at Fukushima included withholding information, profit over safety mindset, and conflict of interest. From the IEEE, they broke holding paramount the safety of the public and avoiding conflict of interest. Similar rules from the NSPE Code of Ethics were broken. The Japanese government had investments in TEPCO that caused them to release as little information as possible, and it gave them special privileges that the Japanese government overlooked a lot of the safety standards that they were requiring for other companies. Fukushima nowadays has become an example for countries of how to not handle nuclear reactors and their issues. Higher ups in TEPCO willingly ignored warnings from scientists that warned them about incoming tsunamis and how they didn't have high enough breakwalls/seawalls. And according to a witness at one of these meetings, he overheard a TEPCO executive talking with an analyst afterwards, asking him to change some numbers within his calculations to make it seem as if their stuff was sufficient.
All right, the impact of this disaster. In March 2011, a devastating tsunami struck the coast of Japan, triggering a catastrophic meltdown at the Fukushima Daiichi nuclear power plant. This event not only led to severe environmental damage, but also had profound societal and economic repercussions. The company operating this plant was called Tokyo Electric Power Company, or referred to as TEPCO. It faced enormous financial losses estimated in the billions of dollars, primarily due to the costs of like cleanups, decommissioning the plant, and compensating affected individuals and businesses. The disaster severely tarnished TEPCO's reputation, highlighting significant shortcomings in its disaster preparedness and safety measures. The incident had a dramatic impact on the health and lives of all the residents and TEPCO's employees as well. Many were subjected to long-term health monitoring due to exposure to radiation, while senior executives faced legal actions for their roles in mishandling this crisis. The broader community around Fukushima was deeply affected as well, such as 100,000 residents were forced to evacuate, with many unable to return to their homes for a long time, as seen in the picture as well, leading to significant mental and emotional stress. Uh, Next slide. All right, so other possible ethical choices. Um, the disaster at Fukushima was unprecedented, but it was not unforeseeable. So, historical data on tsunamis in the region indicated a significant risk that had not been fully accounted for in the plant's safety protocols. So, an alternative approach in the ethical codes of both the IEE and NSP could have made a critical difference. First, let's consider the IEE's motive, which is hold paramount the safety, health, and welfare of the public. If TEPCO and the involved engineers had embraced a more rigorous application of this safety and risk assessments focused on this ethical principle, they might have developed enhanced structural defenses like higher seawalls and elevated backup power systems. These measures would not only protect the nuclear plant, but also the surrounding communities, demonstrating a clear commitment to public welfare. Furthermore, the NSP's Code of Ethics urges engineers to issue public statements on only in an objective and truthful manner. So, in practice, this means providing accurate, transparent assessments about risks and safety measures. By adhering to this principle, TEPCO could have fostered trust and confidence in their operations, ensuring that the community understood and trusted this safety measure in place. So now imagine a scenario where these ethical guidelines were fully implemented. We would likely see a facility better prepared for natural disasters with reduced damage and enhanced safety outcomes, preserving both human life and the environment.
Okay, so some possible outlook for future situations include several key strategies to mitigate risk and prevent similar incidents, such as advanced containment systems. This includes developing durable barriers and containment structures, for example, like higher seawalls, and then investments in advanced warning systems, backup power, such as offsite powers, such as diesel generators, and cooling systems to prevent overheating and core meltdowns. And then regulatory oversight and enforcement. An example would include strong government regulations and then community engagement and transparency. So for outcomes such as financial viability, proactive safety measures would reduce long-term liabilities and ensure costs, enhancing nuclear energy's economic sustainability. And then for changing public perception, demonstrating a commitment to safety and environmental management to rebuild trust and dispel misconceptions about nuclear energy's risks, and potential positive impacts would include safety measures to contribute to climate change mitigation, protect public health, and promote sustainable energy production. A summary of the nuclear reactor would be safety and ethics and engineering is vital. Collaboration and transparency are crucial. And then you need engineers innovated in enhancing nuclear safety. The Fukushima incident reminds us to stay vigilant and ethical, and public safety and environmental protection must be a top priority. And global reevaluations lead to stronger safety regulations. The lesson learned from Fukushima is always put safety first in nuclear projects or any engineering projects to protect people and the environment. And yeah,
Great, thanks, guys. Let's give them a hand.
thank you.
Right. Thank you.
Okay. All right, so next group we have Boeing. This one's probably the one I'm most excited for. So Nick, Natalie, Christian, Yas, you guys are all here?
Hello. Yes, that's correct.
Okay. Nick, I'm guessing you have the slides?
Yeah, I'll share my screen right now.
Okay, I'm gonna make you co-host. All right, go for it.
Okay, you guys can see that?
Yep. Yep, whenever you guys are ready.
Okay, perfect. Okay. Oops. Okay, we are presenting Boeing. The Boeing company is an aerospace manufacturer widely known for making commercial jets for the public, but they also have military contracts and whatnot. The Boeing 737 is actually the most popular passenger airliner in the world currently. It's a little bit of a dated design. It's been out for a while. The newer versions of it, the 737 MAX, are meant to compete with the Airbus A321 Neo. The Airbus A321 is based off of a design made more recently, so it has more room for improvement. So the issue with keeping the 737 alive for this long could be that it's just a little bit too dated, and you'll be pushing it to its limits, making it a little more unstable. But this was because Boeing gave themselves very tight time constrictions to compete with Airbus. And well, the way that they rushed the production ended up being a total disaster for the company's reputation. So we'll start off with a little general history. In 1916, William Boeing, who was a carpenter, he started Aero Products Company, which is now known as Boeing. He was a stickler for quality, and actually, he wanted his name to just mean quality. And one time, he wasn't fascinated with the quality control that his factory had going on. And he wanted that day to just shut it all down, just shut down everything. Someone convinced him not to, but the whole point is he was really dedicated to quality. He would be rolling in his grave today. This went on into the 50s as Boeing Airplane Company started making commercial jets with the beautiful 707 pictured here. And again, just this reputation of being reliable really helped this thing succeed. It helped the whole company succeed. And in 1961, they changed their name from Boeing Airplane Company to just Boeing Company because now they were doing space exploration. The point I'm making is they were doing great because of this reputation for quality. The same cannot be said for a competitor of theirs, McDonnell Douglas. So for this, we kind of fast forward to the 90s. McDonnell Douglas was not exactly doing too well. They had a lot of issues with their reputation. The main one was from the DC-10. So this beautiful plane here, it is big, it's spacious, it's comfortable, but it had a history of crashing a lot. And actually, one of the stories was a door flew off of this plane because of cheap bolts. In this case, it was actually a cargo door, but the vacuum sucked the floor down, and a lot of people actually fell out of the plane and plummeted to their deaths. So this plane had a very bad reputation. McDonnell Douglas tried to revive it by making the MD-11, pictured here. The MD-11 was a much better plane. It was larger and everything, much safer, but you guys can probably see in these images the issue. They look exactly the same, so no one wanted to fly on that shit. This company was just struggling with their reputation entirely, and in the 90s, they were about to hit bankruptcy. Boeing came and saved the day. With one of the worst mergers that could possibly happen, Boeing and McDonnell Douglas merged their company into one. And we could see immediately from this point that the quality just started dropping immensely. McDonnell Douglas managers infiltrated Boeing's company and removed the importance of quality at this company. They made a lot of questionable decisions in the 2000s and stuff, but the one that probably got the most criticism is here in 2011. To the disappointment of many, Boeing announced plans to make a longer version of the already outdated 737. Instead of designing a new plane, A brand new design would be more stable, have more room for improvement or whatever, but they just decided to kind of be cheap and have this unstable design. The issue with unstable designs like this is you could have the plane over assisted. You might have to make software that's a little too sensitive just to make sure the plane is safe. Well, we fast forward not too long after that, and we already see 2 crashes with the Boeing 737 MAX 81 in October 29, 2018, the other one in March 10, 2019. The second one was particularly sad because there was actually a long fight for survival. Both pilots were pulling it with all their might to try to keep the plane flying straight, but the computer kept pushing the nose down. 3 times the pilots were able to take control back and keep the plane level, but after the 3rd time, they were already too low. The computer dove again, and all 157 passengers of that flight perished. So these 346 people lost their lives needlessly because of some software issues with MCAS. To explain that here, this is the maneuvering characteristics augmentation system. It was not mentioned in the manual for the plane. So they were advertising this as nobody needed training for this new software. And they also deliberately lied to the FAA about it. So for both of these crashes, MCAS thought the plane was stalling because one sensor was faulty and it pushed the plane down to stop this stall. Now, what does it mean when an airplane's stalling? That's a wonderful question. You're asking the right guy. Outside of school, I'm actually a private pilot. So I would love to answer this question, is what I'm saying. An airspeed stall is just what happens. You're going too slow and the wings don't work anymore. And the first thing they teach pilots, very first thing, it's like, when this happens, you push the nose down. You push the nose down and the plane speeds up and now you're flying again. All commercial jets do this automatically. Whenever you're stalling, they will automatically push the nose down. The issue with MCAS is it really only took one sensor to not work and it would push the plane down. The airspeed indication was still high and it would still push the plane down into the ground. But the whole issue was the 737 MAX was advertised as being backwards compatible, so pilots of older models could just walk right into this one and not expect any changes, which simply wasn't true. MCAS had a lot of new features to it that needed to be taught, but Boeing deliberately lied to the FAA. So of course, this started a huge scandal and everything, and we thought that that was a learning experience for the company. But unfortunately, the story does not end here.
And so on January 5th, 2024, Alaska Airlines Flight 1282 was leaving Portland, Oregon, and shortly after they had to make emergency landing when a huge deafening bang took out the left side door and gaping a hole in the aircraft, sucking the surrounding door panels, insulations, people's phones, and even in one case, a boy's shirt off his back. It even swung open the cockpit door, knocking the headsets off of the pilots. And fortunately, besides minor injuries, there were no casualties in this case. So what led to this mistake? So on August 23rd, there were minor errors that wasn't involved with the door, like misdrilled holes. But Boeing was working with Spirit Aerospace, where Spirit was beginning the production. And once they installed the door plug, I should mention that the MAX 9 was designed to be bigger and carry more passengers, so they were required for safety regulations to build 2 extra emergency exits. And depending on the aircraft, they could leave the emergency exits on or install, like in this case, the door plug. The aircraft gets to Boeing, and Boeing engineers notice that there are these 5 rivets on the frame, and that warranted a them to report into the CMES, which is the Common Manufacturing Execution System, which when there's any nonconformities, it has to be recorded, repaired, and then have to go through a final checkoff. And so the aircraft was returned to Spirit, and once again, they claim to work and repair the rivets. And once returned to Boeing, they noticed that not only did they not repair the rivets, they just try to cover it up by painting over it. So this warranted another report to the CMES, and there was a heated back and forth on the SATs, which is a situational act tracker where these engineers used to communicate with each other and report like minor repairs that didn't need an official checkoff. And after a heated back and forth, Spirit owned up to their fault, took the aircraft back, and commenced their repairs on the rivets. And when they were starting the repairs on the rivets, they noticed that the pressure seal was broken. And this was crucial because in the repair of the pressure seal, they had to either open the door or completely take the door off. And this was important because if you had to take the door completely off, it warranted a report into the CMES, which had to go through an official checkoff. But someone decided that the door didn't need to completely come off and the repairs could be made just with open. So when they were making the repair and putting the door back in, someone forgot to put in these 4 safety bolts that locked the door in place. So these door plugs operated where they had 12 stop fittings that kept the door from like making any outward movement, and these 4 bolts kept the door in place so it doesn't slide up and down. And so after they made the repair, and because these repairs didn't need to be recorded in the CMES, the production continued. They put the door panels in, and no one noticed that these safety bolts weren't installed. And as you can tell, that led to the door blowing off after takeoff.
All right, so ethical lapse. So as mentioned before, MCAS was the main cause of the 2 planes to crash. And MCAS was not included in the training for the pilots or in any of the manuals. So the reason for this was because the people involved in Boeing, they wanted to save Boeing money by not having to train these pilots and having this information published. This unfortunately did lead to the 2 fatal accidents back in 2018 and 19, with the 346 total deaths and the grounding of all MAXs right after. Getting more in detail about who was involved was Mark Fortner, who was the former chief technical pilot at Boeing. At his time there, he was in charge of providing the FAA with information about the differences between the new 737 MAX and the older models. This information that he would have gave to the FAA would have been published in the manuals and training, but since he withheld that information, that never happened. In October 2021, he was charged with 2 counts of fraud and 4 counts of wire fraud, but in March the year following, he was acquitted. I have a screenshot below of one of his many emails where he talks about Jedi mind tricking regulators into accepting the training. Other emails include discussions about getting rid of MCAS in the publications completely. Next, analysis of ethical dilemma for IEEE. So I tried to choose just one that really encapsulates our case study, which is I1, which is to uphold paramount the safety, health, and welfare to the public, to strive to comply with ethical design and sustainable development practices, to develop the privacy of others, and to disclose promptly factors that might endanger the public or the environment. So that last part I have underlined because I really think that is what encapsulates what really violated this code, or what this case study violated. And for the NSPE, I just chose 3. They all basically mean the same thing, but they're about engineers should be truthful and honest in their work and have that integrity.
So the first person I want to talk about is Dennis Muhlenberg. He was Boeing CEO from July 2015 to December 2019, which means he was the CEO during the MAX 8 tragedies. Muhlenberg served as the president of Boeing from December 2013 to December 2019. However, up until July 2015, Muhlenberg served as vice chairman, president, and chief operating officer. He has a bachelor's degree in aerospace engineering, an honorary doctor of science degree, and a master's degree in aeronautics and astronautics. Since joining Boeing in 1985, his work mostly revolved around Boeing's defense and combat divisions. And although it seems like he had the technical qualifications, he failed to have any ethical concern. Mark Faulkner, who was mentioned earlier, joined Boeing in early 2012 as a technical pilot for the 737 MAX flight technical team. Then in 2014, Faulkner became chief technical pilot for the MAX aircraft developments. Mark Faulkner was the pilot who conducted the test for the FAA to approve the MAX 8 to go into market. However, in July 2018, Faulkner left the company, which was just months before the first crash or any investigation had even started. David Calhoun is the current CEO and president of Boeing, so he is overlooking all the MAX 9 incidents. Calhoun has been a member of Boeing's board of directors since 2009 and served as board chairman from October 2019 to December 2019. He has a bachelor's degree in accounting from Virginia Tech, and his expertise revolves around a wide array of strategic business, safety, and regulatory matters. So after the second crash of the 737 MAX 8, the FAA forced all MAX 8 aircraft to be grounded indefinitely until a proper investigation was conducted. Dennis Muhlenberg needed to testify before the U.S. Senate and House committees as a result of the fatal accidents. Here is where he acknowledged and accepted the fact that he and the company were accountable for these tragedies. But after the congressional hearings, Muhlenberg was fired from Boeing in December 2019. So after the FAA's MAX investigation, Mark Faulkner was criminally indicted by a federal grand jury on fraud charges, but he was later found not guilty of all these charges in a federal court. The company was also forced by the FAA to pay a total criminal monetary amount of over $2.5 billion. And as a result of the recent 737 MAX 9 incidents, Boeing has recently announced that David Calhoun will step down as CEO by the end of this year. And because all these accidents were a result of negligence, the public support and trust in Boeing has plummeted down drastically to the point where individuals will filter out any Boeing aircraft when booking their flights. After the MAX 8 was grounded, the company had to pay $2.5 billion, which is just the tip of the financial iceberg. The sudden switch in management after people step down is a turbulent process for the company. But besides what they were forced to pay, it's estimated that Boeing lost over $2 billion due to the MAX scandal as of October 2023. And Boeing was finally looking forward to good years with the MAX 8 after there was an update to fix the MCAS. However, 2024 had other consequences since they were starting to rush production to catch up with the economy. So with the MAX 9, Boeing has
Natalie, this will be the last slide. You guys are out of time.
Okay, I'll just go to this part then. So one alternate course of action that the company could have taken was just simply being honest about the addition of MCAS and advertising it with the product included. And this would be consistent with the IEE codes and disclosing promptly factors that might endanger the public environment. I don't think I have time for this slide. So.
Yeah, you gotta move on. All right, thanks guys. Yeah, really interesting. I think it's yeah, really, so there's just so much going on with Boeing right now, but you guys did a good job. So yeah, let's give them a hand. Okay, so the last group that we have today is BF Goodrich. Jessica, I think everyone's there with you, right, Jessica?
Yeah, everyone's with me. Is it okay if I share the screen?
Yes, let me make you co-host.
Okay.
Okay, you guys can share.
Share screen. I need screen 2. Share. Oh, I don't know how to put you. There we go. Okay, can you guys see it?
Yep. Whenever
Alright,
you're
cool.
ready.
And then just space.
Okay, so we did our report on the BF Goodrich Air Force A-7D brake problem. So for some context, BF Goodrich allegedly falsified data to win a contract for faulty A-7D aircraft brakes, and then whistleblowers exposed the deception, highlighting ethical breaches by engineers. And then company redesigned the brakes with a safer 5-rotor system, but faced no repercussions until the future. And then the case remains a prime example of ethical lapses in engineering.
Okay, so a little bit of history about the company Goodrich. It was founded in 1870 in Ohio, Akron by Benjamin Franklin Goodrich. As a matter of fact, it was the first tire factory in North America, and its main focus was performance and quality. These two main focuses eventually made it stand out from the rest of the competition later down the line as it was growing. And also his son, Charles Cross Goodrich, allegedly established the first research center or tire research center in America. And throughout the years, Goodrich became well known. It was able to, it showed up in a lot of historical events. It was one of the first cars to cross the U.S. from east to west. Was equipped with Goodrich wheels. So that really brought it up and made it stand out from the rest. Eventually, it found other ways of improving mobility by entering the industry of aeronautics. It was an ongoing thing at the time, due to mainly because it was during World War II. World War II pretty much pushed Goodrich to go for aeronautics.
So the start of the timeline starts on June 18th, 1967, when BF Goodrich receives a contract to supply wheels and brakes for the A-7D light attack aircraft, and then continues on April 4th, 1968, when, after repeated failures, Goodrich's attempts to qualify the brakes through testing proves unsuccessful. And on April 11th, 1968, Kermit Van de Veer, a Goodrich employee, notices discrepancies between the military specifications and the conducted tests. And on May 2nd, 1968, Goodrich conducts another test, pushing the brakes beyond normal use, raising concerns for Van der Veer, who refuses to write a falsified qualification report. In June of 1968, during Air Force flight tests, the brakes fail. And on August 13th, 1969, Senator William Proxmire leads a congressional hearing investigating the brake qualification testing at Goodrich. From October 1968 to October 1969, during that year, key Goodrich personnel involved in the testing resign or are reassigned to a different place. Van de Veer resigns, citing ethical misconduct at the company. And in 1972, Van de Veer publishes an article detailing his experience, bringing the scandal further to light.
So Goodrich and aeronautics. BF Goodrich proved that they could break their limits and continue to push past just making wheels for cars. In 1927, when they moved on to aeronautics, aviator Charles Lindbergh makes the first solo non-stop flight across the world, equipped with Goodrich tires. And in 1981, the Columbia Space Shuttle was also fitted with Goodrich tires, and it was the first wheel brand to be in space. the Air Force A-7D test flight. Let's talk about that. It featured a four-rotor brake. This is pretty much a new thing the Goodrich was testing to test. It was something new for Goodrich, and the Air Force took interest into that, giving them that contract that allowed them to or allowing them to equip the plane or the jet with those with that. And later when tested in 1968, they failed. It was a little bit more about the plane. It was mainly invented for close air support for troops. There was an ongoing war going out, and the Army was pretty much pushing the Air Force to invent a plane that supported the troops on the battlefield. It demonstrated outstanding ground attack capabilities, and while it was primarily designed for ground attacks, it also had limited air-to-air capability. A little bit more context as to what parties were involved in making the brake system itself. The main field was design engineering, and as well as aeronautical and astronautical engineering. Another key factor of engineering were the lab engineers. They were pretty much in charge of testing the design for flaws, seeing if they could pass it on to the Air Force. The main person involved in making the brake system was John Warren, which funny enough was actually the one who introduced that brake system to making Goodrich stand out in the competition. The most challenging technical aspect in testing those brake system was the brake line temperature. Test after test and material after material, the brake lining temperature would always fail, and sadly, it never really got past that point.
So for the economical context, at the time, BF Goodrich was one of the top companies for tires and brakes. And for this contract, they bid $69,417 with the hope of fixing their relationship with Ling Temco Vogue. Because several years earlier, they had messed up a contract with them and were blacklisted by the company. Their primary goal was not to make money off the contract, but to make the money with replacement parts. So they ended up lowballing with the $69,417 bid compared to all the other bids of $500,000 to $1 million. For this, they were manufacturing around 202 four-rotor brake assemblies. This affected the economics when they kept failing because they had to create 14 variations, so materials and all that going into these keep failing. And when they eventually switched from a four-rotor system to the five-rotor system, they had to scrap everything they'd already manufactured for it. So going into the main figures, you have people like Cyril Lawson, who was a young design engineer working on the brakes. You had Richard Glore, who was testing the brake system, who first confirmed Van der Veer's suspicions of the failures of the brake system. You had Ralph Gretzinger, who was a test lab supervisor, who initially refused the falsification of all the documentation, but eventually would give in to the pressure. You had Russell Line, Russell Line, who was the manager and of the technical services section, who ordered Vanderveer to write falsified qualification reports. You have Russell von Horn, who was the immediate supervisor of Sync and over the whole project, who ordered Lawson to qualify the line brakes testing with the words, "no matter what." You had Robert Sink, who was the project manager, who it turned out didn't just not have a college degree, but didn't even have a high school degree. And all of everybody underneath them looked down on him because he was considered uneducated. You have John Warren, who was a designer of the brakes, and H.C. Bud Sanderman, who was the chief engineer over the facility, who initially offered to have someone in the engineering department write the qualification reports when Vanderveer refused to. The personal context for these really break down to 3 different categories of responsibility over it. First one being the ego, meaning when Warner was confronted about the failures in the designs, he passed it off because a junior engineer caught it and he wasn't going to allow it to look bad on him. So he said, just keep testing it, try again. I'm not wrong. The next group was the people to save face, who are Sink, Von Horn, Sanderman, Line, and Bud, who some of these guys, by the time they found out about it, they were already 14 tests in. There was nothing they could do, so they were just trying to make sure it didn't fall on them. And then the last group was the followers, the people following orders, like Vanderveer, Glor, and Gretzinger, who those 3 were told, hey, do this, and eventually they would either comply or in Vanderveer's case, refuse and eventually quit from the company, resign from the company.
So just a quick recap on basically what led to this ethical lapse. They received their order from the Air Force in a joint contract with the Air Force and Ling Temco in June 1967. And as a result, because Ling Temco was part of the contract, it made it highly important for the entirety of the team to try and get them on board, because in an article written by Kermit Vanderveer, when he first blew the whistle he stated that the Goodrich salesman had been trying to get LTV back into a contract with them, but they were unable to do so. So that raised all the concern for them to make sure that they went through with this contract. Now, the design engineer, Cyril Lawson, knew that the final product of the design was inadequate. He was told multiple times about the brake issues for the A7D, which is the parts would disintegrate whenever temperatures reached 1,000 degrees to 1,500 degrees, and the design itself was flawed. But John Warren, the designer of the brake, decided to reject the 5-rotor proposal because they had initially told LTV and the US that they could go with the 4-rotor design, which is something that they hadn't done and was not on the market. So it was new and well sought after by everybody. And
the company. So when we were looking at all the ethical dilemmas of what had gone on, we found out that the engineers had essentially violated all of the IEEE codes of conducts, as well as specific violations from the NSPE. Some of them would be the section 1, subsections E and F, where engineers must not aid unlawful engineering practices and must report violations. There's section 2, subsection A, where engineers must only undertake assignments within their qualified technical fields. And as we stated before, Vanderveer, who was the original whistleblower, lacked prior experiences, but was promoted into a technical role, therefore violating that section. And then in section 4, subsection A, engineers shall disclose all known or potential conflicts of interest that could influence or appear to influence their judgment or the quality of their services. Again, the lead engineers that were in charge of the projects all knew that the brake systems were not up to par and did not meet the standards that were required from the US military, but still decided to go through with it. And finally, section 5, where engineers shall avoid deceptive actions. They purposefully decided to alter all of the testing to make sure that it appeared as if it went through with all of the requirements by the US and by LTV, solely for the reason to get LTV back into a contract with them. But because none of the qualifications were met, they decided to falsify everything. Now, one of the impacts that led because of this was not really immediately shown, because at the time when this was still going on and the hearing had just started, none of the workers who were on the team at the time for Goodrich were fired. And it wasn't until in 1972 when, after the hearing and when Kermit Vanderveer decided to post his own story about what happened from his point of view, he revealed that Russell Line, who was the section manager at the time, was promoted to be a production superintendent. And Robert Sink, who at the time was the project manager, took on Russell Line's position of being a section manager. Now, Goodrich also, because of the hearing, had to be involved with government inspection procedures now, because they were no longer trusted by the government. So with their contract with LTV and the US, they ended up having to deliver a 5-rotor brake like was previously suggested, but because they had initially rejected it, it set them back about 5 months in order to properly deliver what was needed. And in modern day right now, we're still using the Goodrich as a primary case for whistleblowing, even after 60 years. And there have been numerous cases afterwards that have shown other types of whistleblowing, but this is the most prevalent as it's a case that doesn't involve any casualties just yet, but was able to stop it before that. And the A-70 aircraft did end up making a debut later on in the year with the 5-rotor brake in the Luke Air Force Base in Arizona. Okay, so now that brings us to the question of what if. Brings into the question of what if, which is a completely obvious alternative course of action that could have happened if John Warren would have just scrapped the entire 4-disc brake design and made a whole new design based off of Lawson's, off of Lawson saying that it wasn't going to work. They, let me see, which of course it wouldn't have been an easy, simple fix. They would have had to have junked all the sub-assemblies that created the 4-rotor brakes to begin with. They would have had to start a whole new preliminary design and testing, which could have taken a lot longer. And then they had to wait for the new sub-assemblies to come in as well. Plus they had to let LTV Aerospace Corporation know about the redesign and the fact that they had to scrap everything and start over. Then they had to work overtime to meet the June 1968 flight testing deadline, which, I mean, seems like a lot, but they still skip 80% of the nightmare of having to falsify all the reports, all the
pretty much the brake testing in general, the flight test. And then on top of that, no NSPE codes or IEEE codes would have been violated whatsoever. I mean, yes, they probably would have had issues with letting them know, hey, this isn't going to meet the deadline, and that would have been the worst case scenario if it didn't meet the deadline for the flight test. But at least they would have skipped the falsification report. They would have skipped the investigation. There was no wasted time trying to qualify the brakes on top of everything. And if
All right, unfortunately, we're out of time, so go ahead and finish this slide.
sorry, I try to be fast. And if history repeats itself, I mean, the worst that could happen is we just get increased regulatory oversight over such things, you know, stricter guidelines, regulations. There'd be evidence of thorough testing and certifications that we now have to go and process for critical components. We'd have knowledge sharing, advancements in technology and testing, which could lead to investment and funding so that these vulnerabilities and failures no longer could happen. That was pretty much the end of mine.
Okay, great. All right, thank you guys. Yeah, so a lot of really great presentations today. I know it's a lot of information to cover, and I think all the groups today I think did a really good job of doing the research. So thank you guys. Okay, so we'll come back here on Thursday. So the other half of the groups will present then. So make sure you guys come. Even if you presented today, please come on Thursday, see the other groups' presentations, and yeah, you can learn about about these case studies. So thank you, everyone. Great job for those who present today, and I will see you on Thursday.
I have a question.
Sure.
If we didn't finish the presentation, like, would we be able to email it to you or whatever? And then
So I graded you based on kind of what I saw. I'm going to open up a Canvas assignment where you can upload your slides, just so I can take a look at those sections. But I'm primarily going to be grading you on the stuff that I saw in the presentation.
Okay, thank you.
Yep. All right. Thanks, everybody.
Kind of the same follow-up question. We did have a lot left. I don't know if you saw the email I sent you already.
I'm reading it right now, actually.
Okay.
Yeah. So I think what I'll do for you guys, because I know Luke didn't get a chance to speak. I think what I'll do is so I have your guys' rubric right here. Well, that's not your guys. But basically, I think what I'll do is that there's one section of the rubric for the presentation skills. So yeah, I think a lot of you guys' presentation, I think it kind of dragged on because I think you're talking for quite a bit, Brighton. So I think just the points for the presentation skills, I'll dock mostly off for you, and then for the other ones, I'll give them the points for that.
Okay, perfect. Thank you so much.
Yeah.